My name's John Dyer, and it's my pleasure to introduce session 7b, which is about the Terrainer activities. In this session, I think we have an opportunity to report on just a small sample of the Terrainer activities, which are really quite diverse. So what we'll have is a couple of reports on technical projects that are funded by the community. That's on Open LDAP and the IP Telephony Cookbook, and that'll be followed by two projects that have been funded by the European Commission, the Serenate study, which is really a very important strategic study, and the compendium, which Bert van Pixton from Terrainer will report on. So first of all, I'd like to introduce our first speaker, who is Professor David Chadwick from Salford in the UK, and he's going to talk about certificate retrieval from Open LDAP. And what this is really about is X509 attribute passing server XPS. David.
Okay, thanks, John. What do you have to put? All right. So many people don't know that they start to set up PKIs, and they don't know that you can't actually store PKI certificates in LDAP servers and search for them. And it comes as a bit of a shock when they find that the LDAP directory that they thought they could search, they can't search. So our project was actually to do that, to build this feature into Open LDAP. Right. I'm not quite sure where we've got in this flick through now, John. Could you? Can we go back to slide?
In the middle of this one.
Oh, right. I wasn't pressing the middle one. Right. Okay.
This is for us.
Right. That's the pointing. Okay. So which slide are we on? Oh gosh, it's very sensitive, isn't it? Okay. So, what do you do then? So you're in this situation, you've got your PKI, and you can't search for your public key certificates, which you thought you were going to be able to. So vendors such as Entrust say what you have to do is to store an email attribute in the entry of the person, search for the email attribute, and then retrieve the public key certificate that's in that entry. Now, that's a real kludge, a real workaround, but that is, believe me or not, that is what people do today with PKIs. Now, what we decided to do was we thought it's much better if we can search on the fields actually within the certificate, and we can pull the fields out of the certificate and search on it. So that's what we're actually doing. Which one? Oh, we're going backwards again. Right. Okay. So what we decided to do, and Peter Geets was the chap who had the idea initially, was to have a way of pulling out all the fields within the certificate, creating special LDAP attributes for them, storing those LDAP attributes in the LDAP directory, and then clients will be able to search on these attributes. And these attributes can be anything. So they can be the key usage field, they can be the certificate issuer field, they can be the public key ID field, they can be any of the extensions like CRL distribution point or whatever. And if we do that, it means that you can now search on everything within the certificate. So there are 3 internet drafts that have actually been written for this, and those will come on later in the slide. So this is the idea then, that the certification authority, or if you're using attribute certificates, the attribute authority sends the certificate to the XPS server which we're building, and this XPS server then pulls the certificate apart, pulls out all the fields, creates a whole set of LDAP attributes, and it could be as many as 50. I mean, certificates are complex things. Those people who know what's inside a public key certificate, they're very complex beasts. So you could have as many as 50 attributes that you pull out, and you then create a new LDAP entry that's got these 50 attributes in it, as well as the public key certificate. And then a user can type into his normal interface, search for these attributes, and they can be any of these 50 attributes that are defined in these new internet drafts that we've specified. You can search for any of those 50 attributes and say, if you search the entire directory and you find these attributes, return me the certificate that's in the same entry. So the certificate is stored in the entry as well as the attributes that we've pulled out of the certificate. And there's also a feature which we've a configuration parameter here to store the certificate in the parent entry as well. So if a person has got multiple certificates in his parent entry, he can have all his multiple certificates stored as attributes, which is the situation you have today. but also he would then have a whole series of child entries, one per certificate, holding the attributes of all the certificates. So that's the model, and that's the implementation. So the DIT structure, as it shows here, will be as follows. This is my entry, where typically I would have previously been holding all my certificates. I now have new entries for each of my certificates, one for, say, an encryption certificate, one for a signing certificate, one for an attribute certificate containing my roles. And that would be in one part of the tree. Another part of the tree, we do the same for CRLs, which are certificate revocation lists. So you've now got the ability to search for certificate revocation lists. So you can say, find me the certificate revocation list that's got this entry in it. And you can now search and say, effectively, has this certificate been revoked? Yeah? Here is the serial number. Has this certificate been revoked? Is it in one of these entries? And if you get back the CRL, you'll know that it's been revoked. So that's one of the features that's present as well. So how do we name these entries? Well, we've got three ways of naming them. The preferred way is with the X500 serial number and X509 issue. So what we're talking about is, how do we name this arc of the tree? Because the arc of this tree has got to be, A, it's got to be unique, and B, it's got to be automated. We can't have an administrator typing the names in. So we've got to have an automated way of generating unique names. So how we do it is we take the serial number and issuer name, because we know that the combination of serial number and issuer name have to be unique, because that is a feature of X509. The X509 standard says that every PKI issuer must never issue two certificates with the same serial number. And no PKI issuer can have the same no two PKI issuers can have the same name. So we're guaranteed to have uniqueness. So that's our preferred way of doing it. Now, there is a problem with that way. The problem comes from a certain west coast town of America called Seattle. Okay, and the problem is Microsoft don't support distinguished names of that format. That is a standard way of naming distinguished names in LDAP, but Microsoft don't support it. So we have to have a workaround for Microsoft. So the workaround we've done is we've created this new attribute called X509 issuer serial. That's a spelling number, because it shouldn't be issuer serial. It shouldn't be a double S, not a triple S. And what we've done is we've taken both of those attributes and compounded them into one long string. Yeah?
So
Michael?
Why not just say tough, and if their implementation is broken, so be it?
Well, yeah, that was our first approach. But given that they are a force that can't be ignored, and given that people do have them, and you know, we have to provide the whole community with the software, and it's not much extra effort in the entire complex of the code we're building to actually get the two strings and stick them together. It's not a big deal. So we're doing that. So there's that option, and these are configuration parameters. So when you set up XPS, you will actually say, this is the option I'm going to use for naming in my XPS. Now, if you're running an LDAP, which is only for one CA, and you're guaranteed that you're only ever going to store in certificates from one CA, then you can take this third option, which is serial number, because you don't need the issuer name, because it's always the same, and you can just store them on serial number. But the minute you start to store certificates from two CAs, you can't use that third option, because two CAs could issue certificates with the same serial number to the same person, and then you have a clash. Okay, certificate entries, which are the things under CRL. So we just go back to this previous slide here. We see that CRLs, in our initial design, a CRL was going to be a single entry, just like an attribute certificate was a single entry, or a public key certificate was a single entry. But what we realised when we got into the detailed design and started to actually build it, that CRLs consist of information about the CRL, so all that information can be split up and stored in attributes there. But then, for every revoked certificate, there is information about every revoked certificate. So you can't put that information in this entry, otherwise you'd have multiple pieces of the same information in the same entry. So you'd have an attribute type which was serial number of revoked certificate, and that might have 10 values in it. Then you'd have another attribute type which was revocation reason with another 10 values in it. And you'd have another attribute which was the date of revocation, and another 10 values, and then you wouldn't be able to say, find me the particular certificate revoked on this day with this reason or whatever, because they'd all be merged together in one lump. So you've got the option to actually create a tree, but that is an option. If you don't have to create the tree, if you're worried about storage space in your LDAP, you can actually just create the big single entry and say, I just want to find the serial number anyway, and that will work. Okay, so how do we name those entries? Then again, the same way, serial number and issuer is the sensible way of doing it, but if you're Microsoft, you go for the issuer serial, but if you're only using one CA, you could go for X509 serial number. Okay, so what we're going to look at now is how we set up XPS. So XPS, just to give you a status report on it, it's now built, and we're in the debugging phase, and there's a lot of debugging that has to be done because there's a lot of complexity in this. So what I'm going to go through now is show you the configuration file of when you get Open LDAP. These will be all new configuration parameters within the Open LDAP. By the way, the plan is that this software will be in the Open LDAP 2.2 release in September of this year. So if our debugging goes according to plan and we actually get it synchronized with them, then that's the provisional, that's the planned release date. So the first parameter is are you going to switch it on or off? Yes or no. The default is no. So if you get your normal LDAP, Open LDAP, and you load it, you won't be running XPS because it's by configuration switched off. If you switch it on, right, actually this is a slight change because we've just made a slight change to the design and I've not updated the slide to reflect it. Open LDAP, we've designed this so that it can work as a front end to another back end Open LDAP server. Because not everybody's going to be using Open LDAP. Some people might be using Netscape, or not Netscape, but now called Sun One. Some people might be using Critical Path. Some people might be using Microsoft. Only Open LDAP will have this feature. But people will not necessarily want to take their existing LDAP and migrate to Open LDAP. So what you can do is you can actually stick Open LDAP in front of your existing LDAP, and then the original design was we plugged a URL into the Open LDAP. It came in, it parsed the certificate, it then went to the URL and then talked to that LDAP server, which was your existing LDAP server, and then created all this lot in your LDAP server. So that was our original design. But after we'd done original design and built it, we were told by some people that actually LDAP has got at the back end a capability for LDAP to automatically chain onto a back end. You can actually change the database in Open LDAP, and you can have multiple back-end databases, or you can actually have a remote server. So what we did is we pulled out the code that did our referral, and we then found and buried into Open LDAP and used their existing code, and you'll set up Open LDAP using its internal mechanism of having a back-end server, and it will pass it through. So it meant that code we wrote could be thrown away, so that URL won't be there anymore. This next attribute is a configuration parameter to say which attributes do you want us to search on and pull apart. Now, those attributes are all defined in the X509 standard, but we don't know what's going to be defined in the future. For example, that people may come up with new X509 attributes, so we need this to be configurable so you can actually type in the attribute type names. Alternatively, even though these are standard attribute type names, you don't have to use the standard attribute type names. If you wanted to store your public key certificate in an attribute called My Public Key Certificates, then you could do that. And in which case, you'd have to put in here that the public key type would be My Public Key Certificates, and then we would find that attribute, we'd parse it, and we'd pull it apart and use it. So that you can configure on that. Also, on attribute certificate types, you can configure in the attributes that should be trapped for that, and also the attribute types of revocation lists, you can trap that, and so that's totally configurable. Next one, duplicate attributes or not. That's saying whether you want this X509 attribute to be put in the parent entry as well as in the child entry. So you can switch that on or off at will. If you switch it on, you're obviously duplicating the storage, but it does mean you've got one entry with all the certificates in it. If you want to just say, give me that one entry and all the certificates, you can do that. Revoke certificate entries, that's switching on the subtree that we saw in the diagram below the CRL. You can either have a single CRL entry, or you can have a subtree with each revoked certificate in its own entry, with things like its serial number and its revocation date and the reason why it's revoked. Then you can define the format for this is the three different name formats, and as we said, the default is X509 serial number. Sorry, that should be wrong. It should be serial plus issuer. And the certificate RDN format, the default is X509 serial number and issuer, but you can choose the other naming forms if you're running Microsoft, for example. Now, the way we've built this XPS parser is that LDAP does not support transactions. you put an operation into LDAP and it works or it doesn't work, but if you put several operations, you can't group them together and say they'll all work or they all won't work. It just doesn't support transactions. But we need transaction capability because we're going to be creating a child entry and modifying a parent entry, or we might be deleting an entire subtree of entries if someone removes the parent entry. In other words, say, delete my entry, and I've got 6 public key certificate attributes, I'll have 6 child entries, and so you'll need to remove 7 entries. So we need to build a feature of atomic operations and transactions and rollbacks. So we've done that by building a write-ahead log. So when the certificate comes in, we create a write-ahead log. We store in the write-ahead log all the things we're going to do, and then we do them, and after they've worked, we delete the write-ahead log. But if in the middle of doing them it goes wrong, then when OpenLDAP comes back up, it reads in the write-ahead log, and it then rolls back and undoes all the things that's in the write-ahead log. So you define the path where you want the write-ahead log to be. The error log is where all error messages were written to, and again, you decide where you want that to be. And that will also include, if something goes wrong with the rollback, then we will log in the error log. Sorry, we couldn't even roll back. We've got ourselves in a right mess here, and you'll have to tidy up by hand. So that's the situation where something went wrong with the update. It fell over, it came back, it tried to read the write-ahead log, and something went wrong with that, and which means we've probably got a bug in our code, and we'll have to fix it. And then the final parameter is an include statement, and what this does is it includes a whole table which lists the entire set of 50 LDAP attributes that you're interested in. So again, this is all configurable. So if you only want to store, say, 3 fields out of a public key certificate, you're only interested in the issuer name, the subject name, and the serial number, and that's all you're interested in parsing, then your file will only have 3 records in it with 3 ASN1 type definitions and 3 LDAP attribute types. And then as we parse through the public key certificate, we'll only pull out the 3 fields that are specified in this type, and we'll ignore all the rest. So this is driving us and saying all of these ASN1 type references from the certificate should be stored in this equivalent LDAP attribute type, and if it's not there, we won't store it. So again, so that's allowing you to choose as many or as few attributes to be pulled out of the certificate and stored in LDAP as possible. And the format of the record is define attribute, then the ASN1 type reference, followed by the followed by the LDAP attribute type. Now, all of these LDAP attribute types are specified in 3 internet drafts. One written by Peter Geets, and there are 2 written by myself and colleagues at Salford. One's for certificates, public key certificates, one's for attribute certificates, and one's for CRLs. And so all of these attribute type names here, like X509 signature algorithm, they are all defined in internet draft, and that will become an internet. It won't be a standard STRAC, but it will be an informational RFC. And so if you want to know these attribute types put in, that's where you'll get them from. Okay. Parsing the X5 attribute, we've built a compiler that reads in ASM1, parses the ASM1, pulls all the fields apart, and produces the set of modifications that need to be made to the LDAP directory. And those are the routines that have been written for that. That's the the previous one was just saying a bit about the compiler, how it's been made from Flex and Bison, and I didn't do that bit, and I must admit I don't know much about that bit. That was one of my researchers working for me was a compiler expert, did that. The write-ahead log we've talked about, that's where we record all the details, ready for rollback. Now, again, how do we do the write-ahead log names? Because they've got to be unique. So what we do is we take the distinguished name of the entry that's going to be created or modified, and we do a hash on it. So we use a 128-bit MD5 hash, and that guarantees to give a completely unique identifier. So we've now got a write-ahead log file name with a completely unique name, and now if LDAP is multitasking and 2 different people come into LDAP at exactly the same time and they're both trying to alter the same entry, okay, the first one that gets there will hash up the distinguished name of the entry, create this 128 character hash, try and create the file name, find the file name exists, and we'll reject the request saying, sorry, someone else is already working on it. So by doing that, we can actually guarantee that we've solved the concurrency control problem for multitasking LDAP, that no 2 two applications can work on the same certificate entry at the same time. Recovery, we said the interesting thing here is that if you're actually adding stuff into Open LDAP, all you need to record in write-ahead log is the name of the thing you're adding, because at rollback all you've got to do is delete it. The delete's much more complex, because if you're going to delete something from Open LDAP, you've got to read it first, read the entire entry, store the entire entry in your write-ahead log, okay, then delete it, and if anything goes wrong, you've got to be able to go to the write-ahead log and rebuild the entire entry in the LDAP. So the delete is actually more complex than the add. And so we do that. So we actually do a search of the LDAP, search for the entries that are there, and then store them in the write-ahead log before we go and make the changes to the directory. Okay, so that's just saying how it works, that it passes stuff on to the back end of Open LDAP, or it traps them. It only traps the modification operations. If they're search operations, they just go straight through us, because we're not dealing with those. Okay. We're probably running out of time, are we, John?
We have a couple more minutes.
Oh, okay. Well, so the details of the add request then, it first checks to see if it's got any of these X509 attributes in it, and if there aren't any there, they'll just go straight through to Open LDAP, and they'll totally bypass our XPS functionality. If it finds an X509 attribute, it'll then call the compiler, the code that's come from the compiler, which will parse the attribute and produce the modifications that need to be built. And then it will turn those into these entries using this Open LDAP function, and the distinguished name of the parent and the child are added to the while. If duplicate attributes is false, then that will be removed from the parent entry, because we're not going to store it in the parent, we're just going to store it in the child. But if duplicate attributes is true, we'll leave the attribute in the parent, and it'll get stored twice, once in the parent and once in the child. We then add the parent entry, we then add the child entry, and of course there might be multiple attributes. It's possible you'd store in multiple attributes, so there may be multiple children created in this. But if there's any error, we'll roll back and delete everything that we've created. With delete, I say this is the complex one, because we have to search now, search the base, looking for X509 base. Now, Peter Geets and myself have worked together on these LDAP standards, and what we've done is we've come up with a common object class called X509 base. So that means that CRLs, attribute certificates, and public key certificates have all got this same common object class. And that means now when we do a search, we can search for this common object class, and we'll find, so whatever strange mixture of LDAP you've got, and whatever strange combinations of CRLs, attribute certificates, and any other stuff you've got below an entry, we'll find it by searching for this object class base, X509 base. And then the certificates are a subclass of that. Certificate entries are a subclass of it. Attribute certificate entries are a subclass of that, and CRL entries are a subclass of it. So it means that we can actually, in one search, find all of them. Okay. They just modify request. That's anyway. We're gone. And those are the governing internet drafts. So the meeting in the ITF we went to in February. No, it was actually March, wasn't it? In America. Then we had this meeting with the chairs of the PKEX group, and they agreed that these could go along as informational RFCs, and Peter and I are ready now to make them to last calls. So the idea is for the next meeting, which is going to be in Vienna in I think July, then these drafts will be ready for last call. And then they'll have last call, and then they'll go into a holding queue, because the alternative strategy for doing this is called component matching. I haven't mentioned component matching today because but the component matching is a much more sophisticated solution than this. And what component matching does is it takes the public key certificate, it stores it in the LDAP directory, parses it internally, and adds all the fields to its indexes. So the public key certificate is only stored once, but all the components have been pulled out and stored in indexes, and then the clients have to be modified to search on components of a public key certificate. Now, that is the preferred approach, because that's the very elegant approach, and everybody agrees that is the elegant approach. However, that approach requires every single LDAP vendor to update their LDAP directory, and nobody so far has been willing to do that. Now, it was myself and I've forgotten the other guy from Australia who wrote this draft about 2 years ago, because we thought that that's the right way to go, but we couldn't get any LDAP vendors to support us. So that's why Peter Geets came up with this approach. And when we took it to the academic community, said, which approach do you like, the elegant approach or the pragmatic approach, which this is, they said, go for the pragmatic approach. So we changed tack midstream in this project and moved on to the pragmatic approach. But the IETF has said, this pragmatic approach will not be the internet standard. The internet standard will be the sophisticated approach, and we hope by making it a standard, eventually all LDAP vendors will move their servers over to the sophisticated approach, and then this can die a natural death. But this pragmatic approach, I think, will keep us probably going for 5 years, at least, I would imagine. Okay, so those are the governing internet drafts. So this is just some of the pros and cons of this method against maybe the sophisticated approach. The big pro, oops, again, I'm not used to using this piece of equipment.
Well, I think we have to wind it up there anyway,
yeah,
so
okay.
this is a very convenient time for it to crash.
Crash, okay. Okay. So just the last slide, I was just going to say got any questions while you're waiting? Yeah, Michael.
Not so much a question, but a comment.
Yeah.
That for those of us who are trying to build other types of PKIs, like in the bridge certificate environment, where it can take 20 to 30 seconds to discover a path,
Yeah.
okay, in terms of certificate paths that might exist in a global PKI network. This approach is going to have, to say that it's going to have a significant impact is
An understatement, yeah.
It's going to allow us to do things in sub-seconds.
Absolutely.
And
Yeah.
this is, thank you.
Yeah. I mean,
This is great stuff.
you saw the presentation I gave on Monday about performance of LDAP, the fact that LDAP searches, virtually every LDAP server on the market can do 2,000 searches a second. Okay. So once this technology is involved, it means that you'll be able to go to your LDAP server and say, find me the certificate, find me the encryption certificate for David Chadwick or whatever, or find me the CRL with these reason codes. And, you know, it'll do 2,000 of those a second, so you'll bang it, it'll be straight back. Yeah, so, yeah.
I'm not an expert, but I am very interested. Your extraction software covers up one LDAP database, I take it. So
No, it doesn't. That's the whole point now. That's why we've done it this way. It's built into OpenLDAP, so you have to have OpenLDAP as the front-end system. Okay? But you can still run your existing LDAP by configuring OpenLDAP to say it's a back-end LDAP server.
indeed, but it comes up with one enterprise LDAP server.
Oh, yes, yeah, I don't
So
think...
you can't do sort of cross-enterprise.
No, I don't think OpenLDAP has the feature to say there's six back-end OpenLDAPs and go to all of them.
What about
pretty sure it's
CA attribute extraction? Can you just cherry-pick certificates from different CAs, or do you have to focus on one CA?
No, you'd have to run separate. You'd have to run separate XPSs because they can all just have one back end.
I'm sorry, guys. I really have to. It's really interesting, but I'm going to have to wrap this up. If anybody would like to talk to David, I'm sure he'll be available.
Yeah, we're
afterwards.
going to be here after the boffin.
Okay. Can we thank David for that excellent presentation?